Arrays are everywhere in JavaScript, but many beginners only know the theory. In this video, we will solve 25 real array challenges with clear inputs, outputs, and explanations. Pause each task, try it yourself, then compare your solution. In this section, we solve common data lookup tasks that appear in dashboards, stores, permission systems, and deployment tools. A dashboard needs to display only active accounts, not every user in the database. We create a users array, then use filter to keep only the objects where isActive is true. Now we run the script and look at the result. Let's break down why this works. Filter runs the callback for every item and only keeps the items that pass the test. Because only Mia and Ava have isActive set to true, only those two objects appear in the output. Now we show the best practice. Keep a filter callback focused on one clear rule. When the condition is short and readable, the next developer can understand the data rule immediately. For practice, add one more field called status, then return only users who are active and also have status set to verified. This is the same pattern, just with a stricter condition. A store catalog usually needs one exact product, not a list. When a customer clicks a SKU, we write a products array, search for an existing SKU, then search for a missing one. Now we run it and compare both results. Let's break down the result. The first search finds the mouse because its SKU matches MS-02. The second search returns undefined because there is no product with SKU MN-99. Now we show the better habit. Use find when the goal is one item. It communicates intent more clearly than filtering a list and taking the first element. For practice, change the lookup so it searches by product name, then print a friendly message when the result is undefined, because real interfaces need to handle missing data. A team settings page may need to know if admin tools should be visible. We use sum to ask whether at least one member has the admin role, then we run the same check on a second list without admins. Now we run the script and inspect the booleans. Let's break down why the first output is true. The team list contains Sam with the admin role, so some can answer yes. The support queue has no admin role, so the answer is false. Now we show the best practice. Use sum for permission checks and feature checks that need a yes or no answer. It keeps the code readable because the method name matches the question. For practice, check whether any member has the role owner. Then try a second version that checks whether any member belongs to the engineering department. A deployment checklist should only pass when every required step is complete. We start with one unfinished item, validate the list, then mark everything as done and validate again. Now we run the script and compare the two outputs. Let's break down the result. The first check prints false because the rollback plan is not done. After the map step changes every item to done, every item passes, so the second check prints true. Now we show the best practice. Use every when the rule is all or nothing. It is a clean fit for release gates, form validation, onboarding steps, and checklist completion. For practice, add a required field to each checklist item, then validate that every item is required and done before deployment is allowed. In this section, we move from filtering data to reshaping data, which is one of the most common jobs in JavaScript applications. A marketing export does not need the full customer object. It only needs email addresses. We create a customers array and use map to turn each customer into one email string. Now we run the script and check the exported list. Let's break down the transformation map. Visits every customer and returns the email field from that customer. Because there are 3 customers, the final email list also has 3 strings. Now we show the best practice. Use map when the output should line up one-to-one with the input. If you expect the same number of items after the operation, map is usually the right method. For practice, create display labels instead of plain emails. Each output string should include the customer name, a space, and the email inside angle brackets. In this section, we transform raw data into values that are ready for the user interface. These are small tasks, but they appear constantly in real applications. Product APIs usually give us raw numbers, but the UI needs display-ready labels. Let's map each product into a string with the product name and a 2-decimal price. Now we run the script and look at the final array. Let's break down why this works. Map creates a new array, so the original product data stays untouched. 2 fixed with 2 gives every price the same money-style shape, even when the input was a whole number. Now we show the best practice. Keep user-facing formatting obvious and consistent. If prices are formatted in one clear place, the UI is easier to maintain and easier to test. For practice, add one more product with a whole number price, like 12. Your goal is to make the output show $12 with 2 decimal places, not just the raw number. A blog CMS needs clean URLs, not raw titles with spaces and capital letters. Let's map over the titles and normalize each string into a slug. Now we run the script and check the generated URLs pieces. Let's break down the transformation. Trim removes unwanted space at the edges, lowercase makes the URL predictable, and the regular expression handles repeated spaces in the middle. That is why the third title becomes one clean slug instead of keeping several separators. Now we show the better reusable version. When slug creation is a real rule in your app, move it into a small function so every title is normalized the same way. For practice, add the title React State Management with extra spaces between the words. The goal is to still produce React State Management with single hyphens. Now we clean arrays before saving or rendering them. Deduplication is a common backend and front-end task, but primitive values and objects need different patterns. Before saving an article, a blog editor should clean duplicate tags. Since these tags are plain strings, set is the simplest tool for the job. Now we run the code and confirm each tag appears once. Let's break down the result. Set only keeps one copy of each primitive value, and JavaScript keeps the order where each value first appeared. That is why JavaScript and arrays stay near the front, but their later duplicates disappear. Now we show the best practice for simple values. Use set when the array contains primitive values like strings, numbers, or IDs because the intent is clear and the code stays short. For practice, add both JavaScript with a capital J and JavaScript in lowercase. Then decide whether you should normalize tags before deduplicating them. When two APIs are merged, the same user can appear more than once. Because these are objects, set will not solve the real problem. So we key the data by ID with a map. Now we run it and inspect the cleaned user list. Let's break down the algorithm. Each user ID becomes a map key, and each full user object becomes the value. When ID 101 appears again, the value is replaced, so the final array contains one object for that ID. Now we show the best practice. Deduplicate objects by a real stable key. Avoid comparing whole objects as JSON strings because property order and unrelated fields can make that fragile. For practice, change the rule so the first user wins. The hint is simple, only add a user to the map when that ID is not already present. In the final task of this batch, we sort real records by time. Sorting looks simple, but production code should avoid changing the original array unless that is intentional. An order history page needs the newest purchases at the top. We copy the orders array first, then sort by the created at date in descending order. Now we run the script and check that the newest order appears first. Let's break down the comparison. JavaScript dates can be subtracted, which gives us a number in milliseconds. When we subtract A from B, newer dates move toward the front of the array. Now we show the important best practice sort changes the array it is called on, so copy the array first when the original order might still be needed elsewhere. For practice, reverse the rule and show the oldest order first. Swap the two date expressions in the subtraction and compare the output. In this section, we use array sorting the way real product screens use it, with clear business rules, not random ordering. A product catalog should show the strongest products first, but when ratings match, cheaper items should win. Let's write the sort so rating is the main rule, and price is only the tiebreaker. Now we run the script and check whether equal rated products are ordered by price. Let's break down why this result is correct. The first return handles the main priority, higher rating first. Only when ratings are equal do we reach the second return, which puts the lower price first. Now let's show the cleaner habit to keep in real apps. Copy the array before sorting. The sort method mutates the array. So using a spread copy protects the original product data. For practice, keep the rating rule, but replace the price tiebreaker with alphabetical sorting by product name. That variation is common when a UI needs stable and predictable catalog ordering. Now we move into aggregation, turning many array items into one useful result for totals, counters, and grouped dashboards. Every checkout needs to turn cart rows into one number. Here, each row has a price and quantity, so the total is the sum of every line price. Let's write that with reduce, then run it and look at the subtotal. Let's break down the number. The course adds 49.5, the notebooks add 24, and the headphones add 74. Reduce carries those values forward until only one total remains. Now let's show the best habit for reduce. Give it an initial value. Starting with 0 makes the result predictable, even if the card is empty. For practice, add a discount property to one item, then update the reducer so the discount is subtracted from that item's line total. An admin screen needs quick counts of pending, shipped, and canceled orders. Instead of filtering 3 separate times, we can count all statuses in one reduce pass. Now we run it and check the object that comes out. Let's break down why this works. For every order, the status becomes the key in the object. The nullish coalescing part handles the first time we see a status, then we add one. Now let's show why this is the better pattern for dashboards. The reducer does not care which statuses exist ahead of time, so new categories can appear without new if statements. For practice, add one order with the status returned. The reducer should automatically produce a returned count without changing the algorithm. A project board needs tasks grouped under each teammate. We'll use reduce to create one bucket per assignee and push each task into the right bucket. Now we run the script and inspect the grouped result. Let's break down the grouping. The first time we see Maya, Leo, or Sarah, we create an empty array for that name. After that, every matching task goes into the existing array. Now let's show the best grouping habit. Create buckets only when needed. This keeps the code flexible because the assignee names can come directly from the data. For practice, change the push line so each group stores the full task object, not just the title. That is useful when the UI needs the ID, title, and assignee later. This section focuses on nested arrays, where each parent record can contain multiple child records. A reporting script often needs one list of all purchased items, not separate arrays inside each order. Here, every order can produce 0, 1, or many line items. Let's use flatmap, run the script, and check the flattened report. Let's break down the transformation. Each order is mapped to an array of line item objects. Flatmap then removes one nesting level, so the final result is one clean array. Now let's show when this is the best choice. Use flatmap when one input item can expand into multiple outputs or no output at all, like an order with an empty items array. For practice, add product names to the nested items and include product name in each flattened line item. That makes the output closer to a real order export. Now we move into nested arrays. These examples are common in dashboards, catalogs, carts, and reports where one object contains a list of related records. Inventory data is usually grouped, so the category itself does not tell us if something is unavailable. Let's write a filter that keeps only categories where at least one nested product has stock set to 0. The outer filter works on categories, and the inner sum checks the products. Now we run the script and look at the categories that need attention. Let's break down why the output has only electronics and books. Filter keeps a category only when the callback returns true. Sum returns true as soon as it finds one product with stock equal to 0. So kitchen is skipped because all of its products are available. Now let's show the best way to think about this pattern. Use sum when the business rule is an existence check, like any unavailable product, any failed payment, or any unread message. It reads close to the real requirement and avoids manual flags or nested loops. For practice, change the condition from finding risky categories to finding healthy categories. Return only categories where every product has stock greater than 0. That will make you compare sum with every in a real nested array problem. This section is about taking only the part of an array that the user needs right now. That is the core idea behind pagination, rankings, previews, and compact UI lists. A search page should not render every result at once when the user only asked for page 2. Let's calculate the start and end indexes from the page number and page size, then pass those indexes into slice. The important detail is subtracting 1 from the page number because arrays start at 0. Now we run it and check that page 2 starts with the 6th result. Let's break down the indexes with page size 5. Page 1 uses indexes 0 through 4. Page 2 starts at index 5 and slice stops before index 10, so we get exactly 5 items without mutating the original results list. Now let's show the best practice for pagination math. Keep page numbers friendly for users, but convert them to zero-based offsets before touching the array. This makes the UI simple while keeping the array logic accurate. For practice, call the same logic with page 3 and a page size of 5. You should only get the remaining 2 results, because the array does not have a full third page. A leaderboard needs the highest scores first, but we often want to keep the original data untouched for other parts of the app. Let's copy the player's array, sort the copy by score descending, and then slice the first 3 records. After that, we print the original first player to prove the source array stayed in its original order. Now we run the script and inspect the ranking. Let's unpack the pipeline. The spread operator creates a new array, so sort does not reorder the original players list. The compare function puts bigger scores first, and slice keeps only positions 0, 1, and 2. Now let's show the best practice for ranked lists. Treat sort as a mutating method and make a copy first unless changing the source array is the actual goal. This prevents confusing bugs when another component still expects the original order. For practice, reverse the idea and show the bottom 2 players. You will need to sort from lowest score to highest, then slice the first 2 items. Next, we combine arrays from different sources. This is a common front-end task when cached data and fresh API data must become one clean list. A front end may show cached users first, then receive a fresher API response a moment later. Let's merge both arrays but deduplicate by ID so each user appears once. Since the API array comes second, setting the same ID in the map replaces stale cached data. Now we run the script and check that Noah has the updated Pro plan. Let's break down the merge. A map can only have one value for a given key, and here the key is user ID. When ID 2 appears in the API results, it overwrites the older cached value, so the final list has one Noah with the newer plan. Now, let's show the important design choice. Before merging duplicate records, decide which source wins and make the array order reflect that rule. This keeps the code short and makes the data policy visible. For practice, make cached data win instead. The easiest way is to reverse the order of the arrays before building the map. Then compare the plan for user ID 2. Finally, we combine multiple array methods into one business calculation. This is where filter, map, and reduce start to feel like a practical reporting tool. A warehouse report should count only inventory that can still be sold. Let's filter out discontinued products, convert each remaining product into its stock value, and then reduce those values into one total. I'm using named intermediate arrays here, so each stage is easy to read. Now we run the script and check the final number. Let's break down the total. The old phone case is discontinued, so it does not count even though it has stock. The other products are worth 450, 480, and 450, and reduce adds those numbers into 1380. Now let's show the practical readability rule. A chained pipeline is fine when it is short, but named intermediate values are better when each step represents a business idea. That makes the calculation easier to debug and easier to change later. For practice, add one more business rule. Count only products that are not discontinued and have stock greater than 10. This will make you adjust the filter while keeping the map and reduce stages the same. In this section, we turn raw application data into useful business-ready output. The goal is to practice clean transformations without changing the original data. A checkout service often stores cart items in a simple format, but an invoice needs readable labels and calculated totals. Here we use map to create a fresh invoice line for every item, with a label and a line total. Now we run the script and check that each total matches price times quantity. Let's break down why this result is clean. Map returns a new array with the same number of elements, so it is perfect when every input item becomes one output item. Each output object contains only invoice data, which keeps the rendering or PDF step simple. Now we show the better habit for production code: create new objects instead of modifying the cart items directly. That makes the transformation predictable, easier to test, and safer if another part of the checkout flow still needs the original cart data. For practice, add tax handling to this task. Give every item a tax rate, then return a line total, with tax value rounded to 2 decimals. This is the same pattern, but with one extra calculation inside the mapped object. This section focuses on validating imported or user-submitted data. We will use array methods to find records that are not ready to be saved. Import scripts should fail loudly before bad records reach the database. Here we compare every record against the required field list, build a missing fields array, and then keep only records with at least one problem. Now we run the script and verify that only incomplete rows are printed. Let's break down the algorithm. The inner filter checks required field names, not records, and returns only the names that are missing. After that, the outer filter keeps records where missing fields is not empty. Now we show the important validation choice. Define what missing means before writing the rule. In this version, undefined, null, and empty strings fail validation. In a real import pipeline, that decision should be explicit so the team does not accidentally reject valid zero values. For practice, improve the validator so a string with only spaces is also missing. The hint is to check whether a value is a string before calling trim on it. Now we clean messy imported data before using it anywhere else. Normalization makes later filtering, grouping, and calculations much more reliable. Imported CSV rows are usually messy, so we clean them before trusting them. Here, each row becomes a new object with trimmed names, lowercase emails, and numeric amounts. Now we run the script and confirm the output is ready for the next pipeline step. Let's break down why this matters. If emails keep mixed casing, duplicate checks can fail. If amounts stay as strings, totals may become string concatenation or produce confusing bugs later. Now we show the best workflow. Normalize first, then filter, group, or calculate. This keeps the rest of the code simple because every later step can assume the same data shape and value types. For practice, add a status field to the raw rows. Normalize values like uppercase active or space padded pending into clean lowercase strings. This is the same map pattern applied to one more field. In this section, we build small reporting pipelines. We will group, total, enrich, and sort data using array methods that show up often in dashboards and CRMs. A dashboard does not want every single payment when the chart needs totals per month. Here, we take the first 7 characters of an ISO date to get the month key, then reduce all payments into one report object. Now we run the script and check that January, February, and March are grouped correctly. Let's break down the reduce step. The report object starts empty, then each payment chooses its month key. If that key already exists, we add to it. If it does not, we start from 0. Now we show the reporting best practice. Use stable date keys like year-month. Locale formatted strings can change by environment or user settings, but a key like 2026-02 is predictable and easy to sort. For practice, change each month from a number into an object. Store total revenue and payment count, so the dashboard can later calculate the average payment for each month. A CRM needs a quick way to identify high-value customers from purchase history. We first reduce all orders into totals by customer ID, then map those totals back onto customer records, and finally sort by lifetime value. Now we run the script and check that the biggest spender appears first. Let's break down this pipeline into clear pieces. Reduce creates a lookup object, map enriches each customer, and sort orders the final list. Keeping those responsibilities separate makes the code easier to debug when the data grows. Now we show the best way to keep this maintainable. Separate aggregation, enrichment, and ranking. That gives you smaller pieces to test, and it makes business changes easier, like excluding refunded orders or adding a customer tier. For the final practice, add a customer who has no orders. The expected behavior is that they still appear in the ranked list with lifetime value equal to 0, because the fallback handles missing totals. You just practiced 25 JavaScript array problems that junior developers are expected to understand. If this helped you, like the video, subscribe to Dev Level Up, and write in the comments which JavaScript topic you want to practice next.